Alright guys, so I just want to take some time to go over the test that you guys took last week. I understand there was some frustration with some of the questions, so today's objective is just to go through each question, and I'm going to go into a little bit more details about what I'm looking for. Again, the standard that we've been working on for this unit is to be able to construct linear functions and its equivalent forms through a table of values, through a graph, and through two coordinate points. So let's jump right in. The first one said this table of value represents a linear function. Write an equation in y equals mx plus b that represents this function. So right now what I know is that in slope-intercept form I need two things. I need the slope and I need the y-intercept. So to find the slope, given a table of values, you do, as always, the change in y divided by the change in x, or the change in y over the change in x. You don't really need to divide if you like to keep it in fraction form. So -1 to +3 on the y is going to be +4. -2 to +4 on the x is +6. So my change here is 4/6, or 2/3. That means for every 3 x increase, y increases by 2, or every 2 increase by y, on the y, x goes up by 3. But I'm going to go ahead and double check that it works for the next one. 3 to 7 is +4, 4 to 10 is +6. It is still the same ratio of 4 to 6. Even if those numbers are a little bit larger, as long as it's simplest, as long as it's ratio of 2 to 3 or 4 to 6, this is a linear function. So right now, I have y is equal to, my slope is 2/3 x plus b. Well, I have my slope right there, but I don't have the y-intercept. There's a couple ways to do this one. You guys can use point slope form and substitute in 0 for x and output your y. Or in this case, since I already rewrote it in slope intercept form, I'm going to go ahead and algebraically solve for the y-intercept. All I need is values for the x and values for the y. I'm just going to randomly choose this middle one. So I am going to use the coordinate point of 4, 3. This is my x, this is my y. So I'm going to take this y and I'm going to substitute it in there. I'm going to take this x and I'm going to drop it in there. And this is what I have. I have 3 is equal to 2/3 times 4 plus b. I have everything filled out except for b, because that's what I'm looking for. 2/3 times 4 is, well, 2/3 times 4/1. That's what's really happening here. Just multiplying my fractions, I have 8/3 plus b is equal to 3. I subtract 8/3 from both sides. I have 3 minus 8/3 is equal to b. And now I need to subtract 8/3 from 3. I'm going to go ahead and change this in the common denominator by multiplying the bottom by 3 and the top by 3. So I get 9/3 minus 8/3 is equal to b. And b is equal to 1/3. Okay, I'm just subtracting fractions on that side. So there it is. There's b. So my slope-intercept form is y is equal to 2/3 plus, oops, forgot the x there for the input value, the placeholder for input, plus 1/3. And again, just look, this is how I would solve for the y-intercept using slope-intercept form, because it all starts with finding the rate of change or finding the slope. Once you find the slope, you use one of the ordered pairs, the coordinate points you just used, to help you find the y-intercept. It works because this slope-intercept form, this line, this function, runs through each of those points that's on the table. Okay? Alright. Next question here. I'm going to go ahead and move all of this up so that you guys can still have it on the screen. Put it right there so you guys have it on the screen still so you guys can copy it down if you need it. Alright, then number 2. Number 2 says, hey, graph the linear function of y equals negative 1/3 x minus 1 and identify the x-intercept. In this case, this is already in slope-intercept form. Y equals mx plus b. So negative 1 is my y-intercept and my slope is negative 1/3. So go to negative 1, which is right there. And my slope is negative 1/3. Right, just double check here. Yep, my slope is negative 1/3, which means I have a rise over run of negative 1/3. So I go down 1 over 1, 2, 3, down 1, 1, 2, 3, or going the opposite way. It's the same thing as saying 1 over negative 3. So go up 1, 1, 2, 3, up 1, 1, 2, 3. And there is my linear function of y is equal to negative 1/3 x minus 1. And the x-intercept, well, the x-intercept is when you have an x value and your y value is 0 because it sits on this x-axis. And luckily, it's right there. It is nice and whole and clear, so my x-intercept is negative 3 comma 0. Or some of you can just write x is equal to negative 3. I'm going to go ahead and take a moment here and kind of go off to the side, literally, so you guys can see that if I have this function of y equals negative 1/3 x minus 1 and I need to solve for the x-intercept, well, I know if I substitute in 0 for x right here, that's going to be the y-intercept. The x-intercept is when I put in 0 for y and I solve algebraically for x. And multiply both sides by negative 3 because I am just doing the reciprocal, multiplying by the reciprocal here to isolate the value of x by itself. X is equal to negative 3. That's how you would solve algebraically for the x-intercept, in case you didn't want to graph it. Okay, so identify the x-intercept. The x-intercept is right there. It is when y is 0 and x is negative 3 in this case. Okay, let's move on. What is the equation and point slope form of a line that passes through negative 9 and 12 with the slope of 5, 6? Well, point slope form says that I have y minus y1 is equal to m times x minus x1, or y is equal to m times x minus x1 plus y1. So this one is the graphical form. So this one is used for graphing. And this one is kind of the model before you do anything with it. Okay? So you can choose either one and they're both are correct. So here's my point. Here's x1, y1. Here's my slope right there. So I go y minus 12 is equal to 5, 6 times x minus negative 9, which just doesn't look right. So it becomes y minus 12 equals 5, 6 times x plus 9. That's one way. The graphical form of this would be just moving that minus 12, negative 12 to the side. X plus 9 plus 12. Either of these are correct. And that's that one. Okay. Given these two coordinate points, 3, 9, negative 2, 6, write an equation in the standard form. Okay, here we go. So standard form is ax plus by is equal to c. There are a couple ways for you to write this in standard form. So I'm just going to, first thing, I'm just going to find the slope, because I know I need to find the slope. Okay, so xy, I can do 3, 9, negative 2, 6. And the change here from 9 to 6 is minus 3. And the change from 3 to negative 2, well, 3 to 0 is minus 3. Plus a negative, plus another, down another 2, that's minus 2. So that's going to be negative 5. So my slope is negative 3 over negative 5, which becomes 3/5. There's my rate of change. Okay, now that I have my rate of change, you can do it in point slope form, you can do slope intercept form and change it into standard form, but I'm going to do point slope form just because I have a slope and I have a point. And I'm going to use this one. Okay, so I get y minus 9. There's my y1 right there. Here's y1. Erase that. So let's say this is x1, y1 is equal to 3/5 times x minus 3. And I am going to change this into slope intercept form, or I'm just going to get rid of the parentheses by doing the distributive property. So I get y minus 9 is equal to 3/5 x minus or negative 9/5, right? Because I'm just multiplying 3/5 with negative 3 right here. And then here I would combine like terms by adding 9 to both sides. And I get y is equal to 3/5 x. And I'm going to go up here real quick. Negative 9/5 plus 9. Well, I need to make them the same denominator, so make them into fifths. So multiply that by 5, both the top and the bottom. I get 45/9. So negative 9/5 plus 45/5 is equal to 36/5. Okay, and you can actually leave it like that. And if you don't want to leave it like that, you can change it into a decimal and get rid of it later if you want. But 36/5 is going to be 7 2/10. Okay, so let's do, I'm going to go ahead and change it into a decimal. 7 2/10. So that is actually I went from point slope form, kind of the beginning of it, and I changed it into slope intercept form, but I need to go into standard form. But luckily I already have my slope intercept form here, and I just need to move. I'm going to switch colors so you guys can clearly see what's happening here. This is my slope intercept form that I just did. Y is equal to positive 3/5 x plus 7.2. I need to move this unit, this proportional unit, my slope, to the left side. I'm going to subtract both sides by 3/5 x. Okay. I'm going to go ahead and erase. I'm not going to erase that. I'm going to make it just a little bit smaller so that you guys can still see on the screen how to find slope. Okay, so ax plus by. So I had y right here. I subtracted 3/5 x from both sides. So this is what I have. Right now I have negative 3/5 x plus y is equal to 7.2. Okay, totally not cool with that yet because this a right here, the coefficient of x, it needs to be positive and a whole number. Well, if I have 3/5 of something, imagine I have 3 pans of brownie divided amongst 5 students, and I want everybody to have the same amount whole-wise. I just multiply the brownies, I just make it into 15ths, because then everybody will have 3, right? Instead of 1, everybody has 3. So I just multiply everything by -5, in this case, because I want it to be a positive. So the negative times the negative is positive, the fifths cancels out, and I get 3x minus 5y is equal to 36, but in this case, -36, because I'm doing the distributive property. Okay, so my standard form right here is 3x minus 5y is equal to -36. One more time there, write it a little bit clearer. Alright, so 3x minus 5y is equal to -36. And that's the standard form using these 2 points. Just quickly reviewing what's on the screen. I started with finding the slope. I used point slope form right here. I just put it in a point slope form. I went ahead and distributive, combined like terms, and then that changed it into the slope intercept form. To move it into the standard form, I just move this proportional unit called slope over to this side by doing the additive inverse. I subtract, and then I multiply everything by -5 so that I have a is positive and whole. Okay. Alright, so here, and number 5 says, find the equation in slope-intercept form of the line passing through the coordinate point of -6, 5, parallel to the line of 3x minus 5y is equal to 9. So what do we know about parallel slope? Well, parallel slopes, if I were to quickly sketch, whoops, sorry, my pen fell asleep there. So parallel slope looks something like this. Okay. A lot straighter than that though, which means they have the same slope, so they're the same slope, and they have different y-intercepts. Okay, so different y-intercept. Now that I know that, I have this line. Unfortunately, it's not in slope-intercept form. That's actually standard form. So first thing I need to do is change this 3x minus 5y is equal to 9 into slope-intercept form so that I can find the slope and then apply it to the second one. Okay, so here we go. First thing I do, solve for y, so minus 3x on both sides. I get -5y is equal to 9 minus 3x. I divide both sides by -5, and I get y is equal to 9 over -5s plus 3/5 x. It's positive because -3 over -5 is positive. And my y-intercept is -9/5, and my slope is 3/5 x. And that's what I needed. I needed to find the slope, which is 3/5. It looks familiar to the one that we just did. So now that I have this slope, I need to find the line. So pretend like, hey, guess what? I found this one of the line. I need to find the other line that runs parallel to it. Luckily, I know the other line runs through this. Well, I have a slope here. I have a point here. So I'm going to use point slope form. So y, so this is my x1, y1, y minus 5 is equal to 3/5 times x plus 6. The reason why it's adding 6 is if it would have looked something like this. Okay, and a negative becomes positive when you're adding and subtracting integers. Okay, and then I need to go into slope-intercept form. This is what we just did in the last question. I'm going to do the distributive property here, or you can use 0 for x, it's up to you. Y minus 5 is equal to 3/5 x. That's what I'm looking for, that 3/5 x. They have to match up because they are parallel to each other. 3/5 plus times 6 will be 18/5. Positive 18/5, right? Because I'm just multiplying 3/5 with 6 over 1, so that becomes 18/5. And I add 5 to both sides, and I get y is equal to 3/5 x. Let me fix that. 3/5 x plus 18/5 plus 5. I'm not really finished though because I need to combine like terms here, so I'm going to add fractions by making them the same denominator. Multiply the bottom by 5, multiply the top by 5, so 5. This becomes 25/5, right? Because 25/5 is the same thing as 5. And then adding fractions with the same denominator here. 18 plus 25/5 becomes 43/5. Okay, so my slope-intercept form is y is equal to 3/5 x plus 43/5. Let's just quickly change that into a decimal if you want. 43/5 becomes 8.6. So you can leave it as y is equal to 40. Sorry, you can leave it as y equals 3/5 x plus 43/5, or you can go, hey, y is equal to 3/5 x plus 8.6. Either one is fine because this is what we're looking for. Both of these lines, they are parallel to each other. Okay, they have the same slope but different y-intercepts. Okay. All right, that's how you do that one. All right, let's move on to the very last one. Write an equation in point-slope form of a line that is perpendicular to the line of 2x plus 4y is equal to 1. Well, what do I notice? I need to go point-slope form. I have a point. I have standard form. So I need to find the slope. Probably getting a pattern. Once you find the slope or the rate of change of your linear function, you can go from one form to the other back and forth because they all line up. They're the exact same. These two lines, though, are not the same line because they are perpendicular. So in this case, here's a generic example. They form this 90-degree angle, so that means the slope should be opposite and reciprocal. Sorry, couldn't spell that one. Usually you spell check there. Alright, so opposite reciprocal. Alright, so the first thing we need to do, we need to find the slope by solving for y. Changing this into slope-intercept form. Minus 2x, minus 2x, and I get 4y is equal to 1 minus 2x. I divide both sides by 4. Y is equal to 1/4 minus 2/4 x, or y is equal to 1/4 minus 1/2 x. That is slope-intercept form in its simplest slope. And the perpendicular slope of this one is the opposite reciprocal. So if the slope is negative 1/2, the perpendicular slope will be opposite, which will be positive. Reciprocal of 1/2 will be 2. So my slope is 2. Okay, because when I multiply those two together, it equals negative 1. And now that I have my slope, actually this question just says, hey, write it in point slope form. So y minus 8, because here is my x1, here's my y1, is equal to 2 times x minus 6. And that's actually it. There's nothing else we can do. You can change it back into standard form and if you want, but there's no reason for that. So that's how you would do that one. Point slope form, straightforward. Again, all we need is the slope. So that's all I have for today, guys. I hope that helped. Email me with questions. I hope this video helped with test corrections. Again, do your test corrections, turn it into the basket, and then we will set up a time for you to do the makeup test. Thanks, guys.